Think of the sound of rain, a gentle tapping on a window pane, a soft hiss on pavement. It is one of the most familiar, calming sounds on our world. Even in a storm, when the wind howls and drives the water sideways, we understand it. It is just water. It might sting your cheeks, soak your coat, but it is fundamentally gentle. Now, let that thought drift. Leave the gentle water behind and travel with us, hundreds of light years away, to a world that knows a very different kind of storm. A planet called HD 189733b. There, the wind is a permanent, planet-circling gale, moving at 2 kilometers per second. That is not the speed of a hurricane, it is the speed of a rifle bullet. And the rain is not water. In the upper atmosphere where temperatures soar, silicate minerals, the stuff of sand and glass, can exist as a fine haze. As this haze is whipped around to the cooler night side, it condenses. It falls, a sideways rain of molten glass shredding through the sky at 4,500 miles per hour. From a distance, this world is a beautiful, deep sapphire blue. It could fool you into thinking of home, of deep oceans and welcoming skies. But this color is a warning, not an invitation. It is the color of scattered light, thrown back at us by that same fine haze of glassy grains. Like the dust in our own atmosphere that makes our sunsets red, this silicate dust scatters blue light more than any other color. The blue is a mirage, the promise of an ocean on a world where the only precipitation would slice you to ribbons. How can we possibly know this? We have not sent a probe. We have not seen a single drop of glass fall. We know because we have learned to perform an incredible act of cosmic forensics. When this planet passes in front of its star, a tiny fraction of the starlight shines through a razor-thin ring of its atmosphere. That light is our messenger. We can catch it with our telescopes and spread it into a rainbow, a spectrum. And in that spectrum, gases in the planet's air leave behind a unique fingerprint, dark lines where specific colors have been absorbed. By decoding these fingerprints, we can tell what the air is made of. We can even detect the wind because motion stretches the light, shifting its color by a minuscule amount. It is the Doppler effect. The same principle that changes the pitch of a passing siren, but applied to starlight from a world we will never, ever touch. Since we first confirmed a planet around a sun-like star in 1995, we have found more than 5,000 others. This cosmic census has revealed a menagerie of worlds far stranger than we ever imagined. And many of the most extreme share a common trait. They are tidally locked to their stars, trapped in a gravitational embrace. One hemisphere is scorched in eternal daylight, while the other is frozen in endless night. This permanent, brutal temperature difference is the engine that drives the most violent weather in the universe. The planet becomes a machine, endlessly trying to balance the heat and failing. Consider WASP 76b, an ultra-hot gas giant. Its dayside blazes at nearly 2,500 degrees Celsius, hot enough to vaporize metals. The air itself is laced with iron gas, a metallic steam. As ferocious winds carry this iron-rich air around to the cooler night side, it crosses the terminator, the line between sunset and evening. Here the temperature plummets. The iron vapor can no longer stay as a gas. It condenses, like water vapor forming clouds on Earth. It forms droplets of molten iron, and it rains. Imagine a sunset where the clouds gathering on the horizon are made of metal, and the coming shower is a downpour of fire. Astronomers detected this by noticing the signature of iron vapor at the planet's evening edge, but saw it vanish at the morning edge. The best explanation is that during the long, cold night, the iron rained out of the sky. Then, there are worlds that make iron rain look gentle. KELT 9b orbits so close to its blue-white star that its dayside temperature exceeds 4,000 degrees. This is hotter than the surface of many stars. Here, heat is not just a condition, it is a destructive force. The star's ferocious radiation tears molecules apart into their constituent atoms. Iron, titanium, and other metals exist as individual atoms, blasted across the planet in a blowtorch wind. On the slightly cooler night side, these atoms can briefly recombine, releasing a flash of energy that helps power the gales rushing back toward the dawn. The atmosphere isn't just heated, it is being actively dismantled, stripped away into space by the star's fierce glare. This is a world where chemistry itself has become the weather. And it gets stranger. On a planet called K2-141b, the cycle is not made of water or even iron, but of rock itself. This world orbits its star in less than 7 hours. Its dayside is a glowing ocean of magma over 3,000 degrees hot. The rock itself boils, creating a thin, mineral atmosphere. Supersonic winds then whip this rock vapor over to the frigid nightside, where temperatures can plummet below freezing. There the vapor condenses and snows out of the sky. Not snowflakes of water, but of silicon, sodium, and other minerals. A snowstorm of stone falls into the magma ocean, only to be swept back toward the dawn to boil and begin the cycle again. It is Earth's water cycle, evaporation, condensation, precipitation, but with stone on a planet-wide scale, completed in a matter of hours. Elsewhere, the extremes multiply. Some worlds, like HD 86606b, ride long, elliptical orbits that swing them into a furnace every few months. We have watched one heat up by 700 degrees in just 6 hours, a planetary flash fry. Other worlds, like TRES 2b, are darker than coal, reflecting almost no light at all. Their hot, strange atmospheres of vaporized metals are perfectly tuned to absorb starlight and turn it straight into heat, creating skies of unimaginable blackness. And on HAT P7b, astronomers have tracked shifting bright spots in the atmosphere, likely clouds of corundum, the mineral that makes rubies and sapphires. Imagine a sky where the high clouds are glittering veils of jewel dust, forming and dissipating in violent, planet-circling winds. With the James Webb Space Telescope, our vision has sharpened. On a puffy gas giant named WASP 39b, Webb found not just the expected gases, but a clear fingerprint of sulfur dioxide. This molecule shouldn't exist in such quantities on its own. It is likely created by photochemistry, the process where starlight provides the energy to break other molecules apart and rearrange them. We are seeing for the first time with such clarity the sun's light actively manufacturing new chemicals in an alien sky. We are watching chemistry become climate. It is important to remember how we see these worlds. Our knowledge is built from subtle clues in light, averaged over the face of an entire planet. We infer the rain, we model the clouds. We are at the very beginning of this exploration. The exact shape of an iron droplet, the precise composition of a ruby cloud. These details are still on the horizon. Each new telescope, each new observation, brings these impossible landscapes into sharper focus, turning inspired guesses into scientific fact. When you step back, a pattern emerges from these alien hells. Weather, it turns out, is a universal machine. The underlying physics is the same everywhere. Heat flows from hot to cold. Vapors condense when they cool. Wind is just a fluid trying to find equilibrium. These worlds are not breaking the laws of physics. They are revealing the astonishingly vast range of outcomes those laws allow. Swap water for iron, or nitrogen for rock vapor. Crank the temperature dial past the boiling point of stone. Lock a planet's face to its star. The machine still runs. It just produces results that shatter our earthbound intuition. These worlds are a reminder that the universe is not designed for our comfort. It is designed to explore every possibility. Now, come back. Back to a world where the rain does not cut like glass, where the wind rarely breaks the sound barrier, and where the sunrise does not boil the ground you stand on. After a tour of the cosmic default, our own weather feels like a miracle. the gentle absurdity of a cloud made of liquid water, the softness of a breeze. Here, on this small protected island in an unforgiving cosmos, sunset does not mean showers of molten metal. It just means the sky turns beautiful colors. We live in a profoundly strange and gentle pocket, carved out of a universe that is, by its very nature, violent and extreme. The sound of a simple rainstorm is the sound of an exception, a precious and perhaps temporary anomaly. If you find a sense of calm in the vast and the strange, you are welcome here. Subscribe to Stardraft and leave a like if this journey sparks something. We have more to explore, from the nature of black holes to the fate of the last star at the end of time. Thank you for watching.